All right, today we are learning our third method of solving systems of equations. So far we've learned graphing, where we simply graph the two lines on the same graph and see where they cross, or if they cross. Second method was addition, where we simply add the two equations together and one of the variables would cancel out, and we would solve then for the other variable, and then plug that value into one of the two equations, whichever one was easiest, in order to find the remaining point. Remember, when we write these solutions, we always write them as a point xy. Today's method is called multiplication, and it's just adding a step to the addition process. So our ultimate goal for multiplication is that we're going to turn this into an addition problem. So if you look at example 1, we have two equations, and we'd like to add them together so that something cancels out. But if you look, if we add these two together, we'd get x plus 5x. That would be 6x. If we added these together, we get negative 5y plus 10y would be 5y. So nothing would cancel out. So that's a problem, because in order to solve this using addition, something has to cancel out. So we are going to use multiplication to force something to cancel out. Now, what we're looking for is a variable where one number is positive, the other number is negative, and they're the same number, because then they would cancel out. So if this negative 5 were a negative 10, then negative 10y would cancel out with positive 10y. So I could make negative 5 become negative 10 by multiplying it by 2. But the rule is I have to multiply the whole equation by 2. I can't just change the negative 5y. I have to change everything. So I'm going to multiply this equation by 2. And we do that using distribution. So everything in that equation gets multiplied by 2. So 2 times x would be 2x. 2 times negative 5y would be negative 10y. And 2 times 7 would be 14. A common mistake when people do this is that they forget to multiply the 7 by the 2. Everything in this equation needs to be multiplied by 2. Now I have two equations that when I add them together, the y's will cancel out. So I'm just going to add these two. So I changed this equation so that something would cancel out. So 5x plus 2x would be 7x. 10y and negative 10y would cancel out, it would be 0, so I'm not going to write that. And 35 plus 14 is 49. Now I can just solve this for x. Since it's 7 times x, I would divide by 7 on both sides. I'd get x is 7. So I am halfway to my solution. I have the x is 7. Now I'm going to plug that 7 into one of these equations for the x. And again, you can pick which one. It'll work in both, but usually one of them is easier to handle than the other. So I'm thinking, let's do the bottom equation since everything's positive. So I'm going to rewrite the bottom equation, but instead of the x, I'm going to write 7. So it'll be 5 times 7 plus 10y equals 35. And now I just solved this. So 5 times 7 is 35. I'm going to subtract 35 from both sides. I get 10y equals 0. Divide both sides by 10. And 0 divided by anything is just 0. So that's the second half of my solution. So I'm going to write it up here in the point. So 7, 0 is the point where these two lines cross. So the key in multiplication is to pick one of the variables that we want to make cancel out and multiply the equation in order to make that happen. Let's try example 2. Again, nothing would cancel out. If I added these two together, I'd get x. If I added these two together, I'd get negative 9y. So I need to get something to cancel out. If this 3 were a positive 12, it would cancel out with a negative 12. So I'm going to multiply this equation by whatever number I need to make this 3 become a 12. And of course, that would be a 4. So I'm going to multiply this whole equation by 4. First thing, second thing, and the third thing. So 4 times negative 3x is negative 12x. 4 times 3y is 12y. And 4 times 24 is 96. Now, if I added these two bottom equations together, the y's would cancel out. So 4x plus negative 12x is negative 8x. Negative 12y, positive 12y cancels out. And negative 72 plus 96 is 24. Now I divide both sides by negative 8. And x would be negative 3. Remember, a positive divided by a negative is negative. So I am halfway to my answer. The x is negative 3. So now I'm going to plug this negative 3 into one of the x's in one of the equations. This time I'm going to pick the top equation because when I plug negative 3 in for x, negative 3 times negative 3 is going to be positive 9. Plus 3y equals 24. I avoided the bottom one because there's already a negative sign here and here. And if I multiplied the 4 by negative 3, I'd get negative 12, and I'd have 3 negative signs to deal with. And I like working with positive numbers. So now I just solve this equation for y, subtract 9 from both sides. I get 3y is 15. Divide both sides by 3, and I get y equals 5. So that is the other half of my equation, or the other half of my solution. So my answer is 3, negative 5. If you flip your paper over, there's a third example. Again, if I try to just add these up right now, it's not going to work because negative 3x plus 5x would be 2x, and 4y plus 12y would be 16y. So nothing would cancel out. But if this 4 were a negative 12, then it would cancel out with this one, positive 12. So to make this negative 12, I'd have to multiply this top equation by negative 3. So I'm going to multiply everything by negative 3. Negative 3 times negative 3x would be 9x. Negative 3 times 4y would be negative 12y. And negative 3 times 6 would be negative 18. Now I can add the two equations together. 5x and 9x is 14x. These two cancel out. I made that happen. And negative 18 plus 46 is 28. Now I divide both sides by 14. I get x is 2. So I'm halfway to my answer. Now I'm going to plug the x equals 2 into one of these two equations. Again, I'm going to pick the bottom one because everything's positive. So I'm going to plug the 2 in for the x. So it'll be 5 times 2 is 10, plus 12y equals 46. Now I'm just going to solve this for x. So it's, or y. So if I subtract 10 from both sides, I get 12y is 36. Divide both sides by 12. I get y is 3. So in my equation, or in my solution above, I make the y be a 3. In our three examples, we always made the y's cancel out, but you could make the x's cancel out too. I would say whatever's easiest is what you should do. So in this case, it was easier just to multiply the top equation by negative 3 to make those y's cancel out. So just keep in mind, when you're making something cancel, you got to have one number be positive and one number be negative. Okay, that's what you're looking for. One positive, one negative, but the same number. So in multiplication, we're going to force that to happen by multiplying one of the equations by a value.